Good morning, students. Today we will study class 9, chapter number 2, force and laws of motion. In the previous chapter we have discussed about the velocity, acceleration and all. In this chapter we will use that concept also. So first question is here, force. What is force? Now force is defined as it is the external cause. It is defined as the external cause because the force generally exert on a body externally. Okay, so it is the external cause which, number one, changes or tries to change the state of a body. Changes or tries to change the state of a body. It means that body can change or try to change. It is not necessary that the force can change the state, but at least it can tries. For example, suppose just a body jumps in front of a running truck, then a running truck would be there. Running truck would be there. If a person suddenly jumps, it means what? He will not be able to stop this, but it can tries. So that is why it is written here, tries, changes or tries to change. It means that it can exert force, but that force is not so much to stop this, but the force exists there. Number 2, changes or tries to change the shape of an object. Shape of an object. Here again, just if we press a rubber ball, then the shape changes. And what will happen if we press a metallic ball? Then shape doesn't changes. But we have tried a force. We exerted a force. Okay. Number 3, changes or tries to change the direction. Changes or tries to change the direction of a body. It can change or tries to change the direction of a body. Now, what is the mathematical formula? Mathematically, it is given as F is equals to ma. F is equals to ma. Force is equals to mass into acceleration. Mass into acceleration. Mass of the body and A is the acceleration of the body. Then we can calculate the force exerted by a body. And what will be the SI unit? So SI unit of force is Newton. SI unit of force is Newton, and that is represented by N, and CGS unit of force is dyne. And there is the relation between Newton and dyne. What is the relation? 1 Newton is equals to 10 to the power 5 dyne. This is the SI unit. Okay. And now we will define the 1 Newton. 1 Newton generally, here you have seen the 1 F is equals to ma. We are using this. F is equals to ma. If a body is of 1 kg, is of mass 1 kg, moving with an acceleration of 1 meter per second square, then force exerted by it is 1 Newton. This is the force. Now we will see the types of forces. Types of forces. There are number of types. First is contact forces, which you have studied in class 8. I have taught you contact forces. And secondly, non-contact forces. Non-contact forces. This is based on the action of distance. Means contact forces are those forces in which a force is exerted with the physical contact, and in non-contact forces is a force in which force is exerted at a distance. Contact forces, example of contact forces is muscular force, frictional force, and non-contact forces is electrostatic force. Electrostatic force. Electrostatic force, magnetic force. There are some examples of non-contact forces. I have written in the notes. You have I have provided you notes, na? So you can see in the notes electrostatic force, magnetic force, and the next is gravitational force. These all are examples of non-contact forces, because in these forces force is exerted at a distance. For example, suppose there is a charge, or suppose there is a magnet, suppose, because you have a concept of magnet, that is why I am taking the example of magnet only. This is a magnet. If it can attract the other piece of magnet or magnetic material at a distance, not at a distance, it can exert forces and it can repel either or attract. That is why we can say that this is a non-contact forces. Okay, next is, this is the types of forces based on the physical contact. Now next is balance force. This is the topic in class 9th mainly. Balanced and unbalanced force. What is mean by this statement? Balance and unbalanced force. Consider there is a body. Okay, if a force of 10 Newton is exerted from this side, okay, and there are another forces exerting in this direction, that is F is equals to 7 Newton and F is equals to 3 Newton. 10 Newton from this side, and here again 7 plus 3 is equals to 10 Newton from RHS and LHS both. From both direction the forces is 10 Newton. It means both forces can cancel each other, because being in opposite direction they can cancel each other. So cancelling here, the acceleration of body is equals to 0. Acceleration of body is 0. We will call such forces is called balance force. Means balance force, as those balance force definition is, if several forces acting on a body producing no acceleration, that is 0 acceleration, then the body is said to be the body is said to be at rest and the acceleration is 0. Okay, and we can take another example. If there are, again we have taken a body, again F is equals to 10 Newton, and in this direction 6 Newton, and maybe many forces you can take 2 Newton. Again इधर से भी force लगा लो. What is this? F is equals to 3 Newton. The total force is 13 Newton from this side, 13 Newton, and from this side there is a 8 Newton. So such forces are called unbalanced force, because this can produce acceleration, because there is a net force. Net force is not 0, but here the net force was 0, and that is why here the acceleration is not equals to 0 and the body begins to move. Now we will discuss the inertia. What is inertia? It is generally it is defined as the inherent property of every body. Means every body have the inertia. If a body having mass, it must have the inertia. What is inertia then? So it is the inherent property of a body by virtue of which it resists in its present state. It is the inherent property every body have, by virtue of which it resists in its present, it resists the change in its present state, resist the change, resist any change in its present state. It means any change means what? If a body is at rest, suppose a body is at rest, then due to the inertia of rest, which inertia? Inertia are defined in many ways. So means there are types of inertia. So inertia of, due to the inertia of rest, it is not going to be change its state of rest. Means the body is at rest, it will remain at rest unless and force is applied. Even after the applying the proper force, it cannot change its rest state. Okay, now the next is inertia of motion. I will give you the examples of this: inertia of rest, inertia of motion. What is inertia of motion? If a body is in motion, it doesn't want to change its position, means the state of motion, it will continue to be the motion. One of the best example is, suppose you are paddling your cycle. Okay, the cycle still continuing in the state of motion even after stopping the paddling. You have stopped the paddling, but the cycle is in motion continuously, that just because of the inertia of motion. And the third is inertia of direction. Inertia of direction. What is inertia of direction? Inertia of direction, this is the inherent property due to which the body doesn't want to change is the present direction. And what is the example? Inertia of direction. So inertia of direction is the property of a body in which body doesn't want to change the present direction of a body. Suppose you are traveling in a car, suddenly car takes turns. Means if the car takes turns to the left, then the body begins to slide. Generally, just like this, body begins to slide towards right. It is because of the inertia of direction. And what is the example of inertia of motion? A body, suppose a person is in bus, okay, and the bus continue to be in motion, and suddenly brakes are applied, then we lean towards the next seat. Why? Because we lean forward. Why? Because our body wants to continue in the motion. Our body doesn't want to stop the motion, but the bus has stopped. And inertia of rest, what is the example of inertia of the rest? So it is the another example, that is, if a person is traveling in a train and train suddenly starts, okay, then we lean backward. In this direction we lean forward, in this case we lean backward. Okay, this is the inertia of rest, inertia of motion, and inertia of direction. An example is inertia. We can say, you can note this formula: inertia is directly proportional to mass of a body. And many more examples are there, and all are written in the notes, you can see. And in all the example concepts are same. First law of motion. This is also known as law of inertia. Now we will discuss the first law of motion, that is also known as the law of inertia. Okay, according to this, if a body, first I will state you, according to this law, if a body is in a state of rest, it will wants to remain at rest. If a body is in motion, it wants to be in motion until a force, external force, unbalanced force is applied on it. If according to this law, if a body is at rest, it will remain at rest. And if a body is in motion, it will continue will be in motion until or unless an external force is applied on it. This is the first law of motion. If a body is at rest, the body will continue be at rest, and if the body is in motion, it will continue to be in motion in the same direction unless an external force is applied on it. This is the first law of motion, that is also known as law of inertia, what we have